Find the value of k. In this problem, an internally focused stadia is used to measure the distance between points A and B. The coordinates of point A and point B are given in units of feet using a standard XY coordinate system. From the measurement, the value of S1 equals 1.22 feet. To find the value of k, we'll first start with the equation d equals k times s plus c. If we isolate the k term, we get k equals d minus c all divided by s, where variables k and c represent constant values which are specific to the stadia used for the measurement. Variable d represents the slope distance between point A and B. The variable s represents the stadia intercept. Since the problem states the stadia is internally focused, we know the value of c equals 0 feet. The slope distance d can be determined since we know the coordinates of points A and point B. Using the Pythagorean theorem, we can solve for the slope distance by plugging in the coordinates for points A and B, and the slope distance equals 113.84 feet. The stadia intercept, s, equals the value of S1 times the cosine of the angle of inclination, alpha, where the angle of inclination is the angle line segment AB makes with the horizontal axis. Since we know the coordinates of points A and B, we can determine the angle of inclination by taking the arctangent of the quotient of the difference in y coordinates divided by the difference in x coordinates for points A and B. Plugging in these four coordinate values, the angle of inclination equals 21.078 degrees. Next, we need to plug in the value for S1, which the problem statement provides as 1.22 feet. If we zoom in on point B, we can identify the length S1 as the distance between the top and bottom crosshairs when viewing the measuring rod through the stadia. In this diagram, the angle of inclination, alpha, is the angle between the line intersecting the center crosshair and the horizontal axis. If we draw a line perpendicular to the line intersecting the middle crosshair at the measuring rod, then our value for the length s equals the length along this line extending between the lines which intersect the top and bottom crosshairs. If we zoom in yet again, we notice lines S and S1 form two right triangles where the angle created by the intersection of these two lines equals alpha. Without changing the length or angle, we can translate line segment S to the left so as to create one larger right triangle, where the hypotenuse is length S1, the side length is length S, and the angle between these two line segments equals alpha. This shows why we can use the equation S equals S1 times the cosine of angle alpha. If we plug in the known values of S1 and alpha, the stadia intercept, S, equals 1.138 feet. If we recall our values for variables d and c from earlier in the problem, and plug in all three variables into our equation for k, the value of k computes to 100. When reviewing the possible solutions, the answer is A.